So, Nicholas, how is it going for you?
Pretty good. It takes me a while, but get it like
Okay,
as I go on.
right. So we began with linear systems, right? And we have done
Yes.
actually a couple of ways to solve a linear system. As you know, a linear system involves more than one equation, more than one
Hmm.
linear equation, right? So we began with solving linear system with graphically and then substitution method. Today we'll talk about the elimination method, right? So let me share the screen with you and then we'll discuss further. So you can see the screen, right?
Yes.
Okay. So that is the linear system chapter which we are working on.
Hmm.
We have already discussed basics about the lines. We understand what a linear system is. We also know
Yes.
how to solve a system by graph and how to solve a system by substitution. We took up some real life examples, and today we are going to do
Solve
solution
by
by
elimination.
elimination method, right?
Uh-huh.
So just review a few pages. So here is a linear system which we talked about earlier, where the equation of line was y equals 2x minus 1 and 3x plus 2y minus 6 equals to 0. So the first line is given in slope and intercept form, the second one in standard form. So there are two lines represented by two different equations, they form a system. If these lines intersect, we say they have a solution. We say
Solution.
consistent, right? Now, graphically, you could actually graph these lines by making a table of values as shown here for the very first line, which is y equals to 2x minus 1, and you get the line in blue. You can actually also graph the second line using x and y intercepts. The x and y intercepts for the line given in standard form is x-intercept of 2, y-intercept of 3.
Interceptor.
Joining them, you get a line. So that point where it joins is actually the solution of the system. When you solve by graph, you may not be in a position to read the solution exactly, right? At times, as in this particular case. So, it is always better to do with some other system.
Hmm.
So we solved with substitution method.
Yes.
Here we took an example. So we had two examples on this page. 2x plus y minus 4 equals to 0 and x equals to y minus 2. Now we know that y is equals to x minus 2. You can substitute this value
To
back
this
into the
insert.
first equation and solve. When you solve, you'll get the solution for x. And once you get the solution for x, substitute back and get the y value, right? So that is how we did it. In part B, we had the equation x plus y equals to 5 and x minus y equals to 3. Now it is your choice to isolate one of the variables. So we thought it easier to isolate x from the second equation. So we wrote x equals to 3 plus y, substitute that value back in the first equation,
Hmm.
solve for y and then x, and we got our solution as 4, 1. It's a good idea to check your solution also. So if
Yeah.
you substitute this value of 4 and 1 here, 4 minus 1 is 3, it works. 4 plus 1 is 5, it works, right? So that is how you could also check your solutions. Then we took up some word problems and their
Hmm.
solutions, correct? So these are the word problems which we took, and then we see how to solve them. While
Yes.
solving, we adopted both the methods. You could solve by graph or by substitution, right? As shown here. So likewise, we did many solutions. Now that brings us to another set of questions. We'll talk about this example later. Let me now begin with the elimination method, right? So then we'll know exactly, given a scenario which is of linear systems, how to solve it, right? You could adopt
Mm.
different methods at different times. So let's equip ourselves with all the tools, right? So in this particular session, we are going to focus on strategy to solve linear system by elimination method. So these are a few steps which can help you solve a linear system. If you want, you can take a picture of this page and then we'll move
Yes.
forward.
Okay.
So whenever a system is given to us, it's a good idea to simplify your equations to avoid decimals or fractions. Many times you're given a linear system and some equation will be in fractions, some in decimals. It makes things very difficult. So if you're given equation in decimals or fractions, in case of decimals, you can multiply by 10,
Hmm.
100, or some value like this, so that you avoid decimals. In case of fractions, you have to multiply by the lowest common multiple or greatest common, yeah, right, lowest common multiple to
Yeah.
avoid all the fractions. So we get your equation in a form which is without fractions and decimals. And now the second step should be express your equation in the form ax plus by equals to c. So even if it is given in standard form, take c, the constant term, to the other side. That helps, okay? Then number all the equations. Now you are also beginning with 1 and 2, two
Yeah.
equations, number them. It is good to communicate. That's why we would like to number the equations initially. Then you have to choose a variable to eliminate. So when you are given two equations, you have to observe which variable should I eliminate, and then make the coefficient of that particular variable same or opposite, add them
Yeah.
up and then eliminate. Well, later steps, we'll come back to these steps with the help of an example. That will be better for us, right? So let me begin with an example here. Example 10 for us is solve the system 3x plus 2y minus 8 equals to 0 and 2x plus y equals to 6. Now, in this particular case, you could use the method of substitution also, right? You can isolate y. Y will be
Yes.
minus 2x plus 6. Substitute
And then
in the
do
first
3x
equation. Yeah,
2
and then solve,
times.
right?
Yes.
So the options are open. You could also graph them and get your solution. No problem, right? Now, but let us see how to do the solution with elimination method. So given the equation 2x plus 2y minus 8 equals to 0, 2x plus y equals to 6, fortunately, they are not in fractions or decimals. So we need not simplify them. However, we'll write them in the form ax plus by equals to c, and then we'll number the equations, right? So 3x plus 2y minus 8, taking 8 to the other side, gives us 3x plus 2y equals to 8, right? And we are going to number this as equation number 1. Is that clear to you? So we
Yes.
simplified, writing it in the form of ax plus by equals to c. The second equation is already given in that form. That's fine. Just copy it as such and number it 12. Now we have to check which variable can we eliminate easily. Well, y will be easier to eliminate,
Y,
right?
yes.
Because if I multiply the second equation by 2,
By 2.
I get 2y, right?
Yes.
So that becomes our strategy. That's our thinking going on. So eliminate y by making the coefficients of identified variable, which is y, same, right? So we'll want to make this coefficient as 2. That means the second equation should be multiplied by 2, right? So that is the strategy.
Yes.
So multiply the second equation by 2. See, the numbering helps to communicate. The second equation was 2x plus y equals to 6. When you multiply that, what do you get? When you multiply this equation by 2, you get 4x plus 2y
4x plus
equals
2y.
to 12. We'll number this as equation number 3. Clear? Now, we need to eliminate y. So we have equation 1 and 3 to work with, correct?
Yes.
So if I subtract 1 from 3, I can eliminate y. 2y cancels away, right? 2y cancels away. Perfect.
Yes.
Now you have 4x minus 3x, which is x. And on the right side, 12 minus 8, which is 4. And you get your value for x, which is x equals to 4. Is that step clear to you?
Yes.
Once you get x equals to 4, substitute the value of x back into your original equation. So we are putting it back in equation number 2. 2 times x value of 4 plus y equals to 6. Now you can solve for y. Isolate y, and we know it is x minus 8. This should be, 6 minus 8. There's some typing error here, right? So when you solve for y, you will take this 8 on the other side, you get 6 minus 8, correct? Which is equal to minus 2. Perfect. So you get your y value. That means now you have a coordinate point. It is always necessary to write the coordinate point as your solution, right? So these two lines intersect at a point 4 minus 2. It's a good idea to verify your solution also. You can substitute back the point 4 minus 2 into your equations and check if right side equals to left side. If that is the case, then you're sure that your answer is correct. Write your answer clearly as shown here. Are these steps clear to you?
Yes.
Okay. So let's go back to our steps once again. And now I would like you to read all the steps a bit loudly so that we all can hear and tell me if you understand them. Yes.
Okay, so we have, first off, we have simplify equation to avoid decimals or fractions.
Mm.
And then we have express both equations in the form of ax plus by equals c.
Mhm.
Number the equations, 1 or 2, or so on. And then it says choose the variable to eliminate.
Mhm.
Make coefficients of that variable same or opposite.
Mhm.
Add or subtract the equations to eliminate the selected variable.
Correct.
Solve the resulting equation for the other variable.
Mhm.
Substitute calculated variable in any of the equations to find other variable.
Correct.
And verify this order pair can satisfy both of the equations.
Is that clear to you?
Yes.
Perfectly fine. So we'll take a second example which involves decimals. So now in our example, we need to solve a system which has an equation x plus 2y equals to 4 and 0.2x plus 0.3y equals to 1. Perfect. The second
Yes.
equation in this case has got decimals. So the step simplify equations becomes very critical. First equation is as such, we wrote it and we gave it a number 1. The second equation is 0.2x plus 0.3y equals to 1. You should multiply by 10 to get rid of decimals,
Even numbers.
right? So you got it as
Yes.
2x plus 3y equals to 10. Don't forget to multiply the right-hand side by 10 also, right? Sometimes that will be a
Yes.
mistake. Now, clearly, we need to identify one element variable which we should cancel. Well, that seems to be x, correct? Simpler to
Mm-hmm.
cancel. So we could now
Yes.
eliminate x. How will you eliminate x? Tell me.
You would bring 2y to the side where 4 is, and then
No,
we'd
no,
have
eliminate.
x.
Eliminate. No substitution. To eliminate, we want to make the coefficient same. That means we should be multiplying this particular equation by 2, correct? Then it becomes 2x and 4y. Now 2x will be same, we'll cancel them. You get the idea. So try to
Yes.
understand elimination method now. So we identified that x is the variable which could be eliminated very easily. If I multiply equation number 1 by 2, I get 2x. I already have 2x in my second equation. Taking one equation away from the other eliminates x, right? 2x minus
Yes.
2x is 0. And we'll get the value of y. That is what we mean when we say find the value of the other variable. The other variable is y. We eliminated x. Once you find y, substitute y, get x. And then you have a coordinate point to check. Perfect.
Mm.
Can you read from this step, eliminate x onwards, and let me know if you understand the solution?
Sorry, sir, my phone just turned off. Wait a second. Okay, there we go.
You're the other way. Yeah,
Uh,
fine. Yes.
okay, so it says eliminate x by making the same coefficient or of identified variable,
Mhm.
multiply 1 by 2.
Yes.
So it becomes 2x plus 4 equals y.
Correct.
So now we subtract 3 from 1, so it becomes negative y equals 2, and then y equals negative 2.
Correct.
And then it goes to x plus 2 times negative 2 equals 4. And then x equals to 4 plus 4, which is 8.
Correct.
And then we have the coordinate points, which is 4 and negative 2.
Yes.
And then by verifying, we just add in our x to the x and y.
You get the idea.
Yes.
So these are very simple steps to adopt, but if you adopt them like shown here, you're sure about getting the right answer, right? So once again, simplify your equation as we did in this particular
Yes.
case, multiplied by 2, the second equation, avoided decimals. Then we wrote both the equations in the form of ax plus by equals to c. We always number the equations so that's easier to communicate. Choose a variable. In this case, x was the variable chosen. To make the coefficient same, we multiplied equation number 1 by 2. Add or subtract. Now, when they are exactly same, 2x, then you have to subtract, correct? If they are opposite, then you have to add. So we subtracted one from the other to get the value of the other variable. We found our answer, right? And then we verified the result. So these are the steps which you need to adopt to find solution using elimination method. Is that clear to you?
Yes.
Perfect. Now it's time to take some application questions. So I would like you to read example number 11. Here's the word problem. Let us see how to solve this word problem. Okay.
So it says a student sells t-shirts to raise money for the library. The cost of the t-shirts includes a designer cost of $800 plus $4 per t-shirt. The t-shirt sells for $20. How many t-shirts could be sold to gain a profit of $10,000?
Correct. At least $10,000. Okay.
Yes.
So when there is a word problem, we have a strategy, right? We discussed this strategy earlier while solving word problems based on substitution method. So first step always should be to define the variables, right?
Mm,
So the question says, how many t-shirts should be sold? So let these t-shirts to be
T
sold
is
be
t-shirt.
n. So that gives
Mhm,
you the variable itself. What we are asking for, let that be the variable, right? So let
mhm.
n be the t-shirts sold. Now we have
Yes.
to write the equations. Every statement gets converted into an equation, as you know, right? So first equation is the cost of the t-shirt include,
T-shirts.
so that is the cost. We are saying cost is C for us.
Yes.
Fixed cost of $800
$800 plus
and 4
$4
per means
per
times
t-shirt.
10. So
Yes.
multiplied by 4n. That is one equation.
Mhm.
The second statement here is the t-shirt sells for $20 each. Means 20 times n will be our
And
revenue. Revenue is
uh,
the number times the rate.
yes.
So
And
we get the revenue. Now, when we want to have a profit of 10,000, profit really means revenue minus cost.
nice
When you
cost.
do that, you
Get
can equate
10,000.
this equation and you can find your
Okay.
solution. Correct? Now, in this particular solution, what you observe really is that you had no need to use elimination or substitution method. You
Yes.
definitely had more than one equation to work with, right? But sometimes in such situations, you see, neither of the method is required. You straight away get your solution. Perfect.
Mhm.
So the idea here is when you're working with number of systems, at times you may solve using a graph. At times
Mhm.
you may solve using substitution method. At times you may need to do it with elimination method. At times
Mhm.
the variables are so chosen that you get your result straight away, right?
Mhm.
Equating the two, since the condition was given to us, we could easily find it, right? There are a
Yes.
lot of conditions given to us. And now just rearranging the terms, you
And
clearly
then
find
just
your
simplify.
answer and write down
Yes.
your answer as shown here. Perfect. This is also a
Mhm.
linear system. Now, how I have seen this question many times in the test paper is provide a solution by graph and explain your solution. So in that particular case, you have to draw a graph, one to represent the
Mhm.
cost, the other to represent the revenue. The third one is difference between cost and revenue, right? Which gives you profit. And a line which will be
Mhm.
10,000 will give you the point where you have the solution.
Where you have
So
yes.
this question can be rearranged in so many different ways so that you may have to solve using four different equations or four different conditions
Mhm.
graphically. So I'd like you to focus on this, kind of try to solve this question graphically. You will understand what I'm trying to say. Get
Okay.
the point? Draw a
Yes.
graph for each and every line separately and then show me the result, right? Of course, when you draw a line for profit, then profit is cost minus revenue, right?
Yes.
And don't equate 10,000. We have to write a line on 10,000 and get the point of intersection, right? So
Yeah.
let this be an exercise for you. Is that okay? Now, let me discuss with you another type of very important question, which is normally seen in a test paper. So, on a linear system, example 18, Nicholas, can you please read this particular question?
Okay. So it says Nicholas has $10,000 to invest. He invested part of it in terms to deposit, paying 4% per year, and remained in bonds, paying 5% per year. If the total interest after 1 year was $450, how much did he invest at each rate?
Correct. So, Nicholas invested $10,000 in two places. One, 4% interest, Second, 5% interest.
Percent.
Total interest earned in 1 year was $440, right? That is the situation
Yes.
given to you. So how much did he invest in each? We don't know. So we'll have to define a variable, right? So the question says, how much did he invest at each? Clearly, you have to
Mhm.
define a variable. How much in each means X and Y, okay?
Yes.
So we select X amount at 4%, Y at 5%. Clear. But the total amount he had is X plus Y, and that is $10,000. Straight
10,000.
away, we get one equation. The second equation comes from the interest. Now, if I say
Mhm.
4% interest per annum, it means amount
It's 0.
invested times percent interest. Percent means
Mhm.
4 divided by 100, 0.04.
0 is for
5%, 0.05. Correct?
5.
So 0.04 times X is the interest earned on the part which was invested on 4%, and 5% on Y means 0.05 times Y. Total interest earned is $440. You get your equation. As soon as you get your equations, number them. So we number them as equation 1 and 2. Now we need to solve. First strategy is avoid the decimals. You understand?
And multiply
That means you have to multiply by 100 to avoid the
by
decimals.
100.
We did it.
Yes.
We multiplied by 100. We got a very big number here. 440, 100 doesn't matter. At least we avoided the decimals.
We can,
Then we
yes,
had,
we can
correct?
simplify.
Follow your steps. Now we have 4x plus 4y, and the first equation is x plus y equals to 10,000. So now you could eliminate any variable you want. So we chose to eliminate x by multiplying this particular equation by 5. So when you multiply this by 5, right, you get 10,000 becomes 50,000, right? And 5x, 5y. Now taking the difference between these two equations, you can eliminate 5x, uh, uh, 5y and 5y you could eliminate, and this difference will give you the value of x, right? 5x minus 4x is x, and then 50,000 minus 44,000 is 6,000. Do you see that?
Yes.
So immediately by elimination is the best and very powerful method. We get the value of x. Now, we can also isolate y from here, right? Y is 10,000 minus x. So write 10,000 minus x, which is 10,000 minus 6,000. So 4,000 was left to be invested at 5%, and we get our answer. Clearly, the answer is 6,000 invested at 4% and 4,000 invested at 5%. Is that clear to you?
Yes.
Easy and simple. Now here I like to share with you another method of solving this particular question, right? I'm doing it on a purpose, and that is to say, many times it is kind of important to write the information in tabular form. If you put the information in tabular form, it becomes simpler to write down the equations and then solve. So we have similar question. I just changed the name and the amount. So this time I'm saying Anna invested 5,000, correct?
Yes.
So he invested part of this at 5% per year and 7.2% per year. If the total amount was 349, what was the amount invested in?
How much did
Exactly same question, but just change some name and the variable values. Is that clear to you, right?
Yes.
Now let us see, how do we do the same question using a particular table method, right? So I'm calling this as my alternate method, right? So let's recall the formulas. Simple interest is I equals to
I
PRT,
equals
principal, rate, and time.
rate and time.
Where rate is given in percent, time is in years. In this case, 1 year means T is 1, correct? So P is the principal invested, R is the rate of interest, T is the time in years. You have to convert the percent values into decimals, which we did here on the left side, just as we did in the previous case, correct? So these are the things which you should know about interest related questions, right? Now see, we have made a table which says we're interested in 3 things: amount, interest, rate, and interest itself, right? So the amount we don't know, how much did we invest? So we invested X and Y amounts. X amount at 5%, Y amount at 7.2%.
7.2.
When I say 5%, decimal value is 0.05, 7.2 is 0.072. The interest earned is the product of all this, correct? So you just multiply with X and with Y, you get your interest. But we are given that the interest actually is 349. So we wrote that 349 here, right?
Mhm.
And we are also given that the amount to begin with was 5,000. So
5,000.
you have a table there, all the information in the table. Now, this table is very simple to read and write the values. First equation we get from this particular column, x plus y should be 500, right? That's the total. So we get one equation, x plus y equals to 500. The second equation we are getting from here, which is on the interest side, right? So second equation is 0.0x plus 0.0 equals to 349. Is that clear to you?
Yes.
I actually adopted the method of substitution in this particular case. So I went
Yes.
straight without numbering. So in substitution, well, numbering is important in both, but now since you know the methods,
Yes.
what I did was x plus y is 5,000. I isolated x and
Solve
wrote
for
5,000 minus y
yes.
so that I could substitute the value of x in my second equation.
5 point.
You see that?
Yes.
So 0.05 times 5,000 minus y, I'm just keeping my decimals since I need to use the
Yes.
calculator. While using calculator, decimals doesn't bother us much, right? It all
Yes.
depends what type of test you're dealing with. Whenever
Yes.
you're in IB program, one set of questions are based on without calculator, the other
Yes.
one is with calculator.
Is with
If the calculator is allowed, why not use decimals or fractions?
decimals. Yes.
Doesn't matter, right?
Yeah.
With calculator, it doesn't matter, right? So assume that this is the test with calculator. Perfect. So we are not bothering about
Mhm.
converting decimals to whole numbers and adding on few steps. But that becomes important if calculator is not allowed, correct? So calculator is allowed, we just substitute the value and expand, and then you have an equation in variable y. Figure that out. Once you find the value of y, you know x is that total amount minus the y value, and you get your answer for both x and y. Now you can clearly write down the answer. So 500 invested at 5% and 4,500 invested at 7.2% was the result. What do you think about this method?
Yes. I get it.
Correct. So you know both the methods. You could actually begin by defining our variables as we did earlier, right? So and then you can get your result converting the figures into the way we did for elimination method, or you could also do the substitution method. Now, table of values as shown here is very, very important. You could use this for elimination or substitution method, right? So let me
Yes.
take another example with you, and this time we'll take a distance, speed, time. So you know the relation between distance, speed, and time?
Distance,
That
speed, and
particular
time.
triangle. So what is
Yes.
distance equals to in terms of speed and time?
So if you have like let's say you don't have time, you could do distance divided by speed, which will give you time, or you just use whatever you have.
Perfect. So distance is equals to product of speed and time, and speed is distance over time, time is distance over speed. So clearly that triangle gives you a visual on the relation between distance, speed, and time. Perfect. Can you please read this example number 14?
So it says Sam drove 500 kilometers from Toronto to Windsor in 5.5 hours. He drove part of the way by at 100 kilometers an hour and the rest of the way at 80 kilometers an hour.
Correct.
How far did he travel at each speed?
Correct. Now, how far did he travel at each speed? So we are interested in finding the distance, right? So what I did was I again made my table of values. So we're talking about a journey which has been done in two parts, part one and part two. In part one, rate means the speed, right? So in the column, we know distance, speed, and time. So we have three columns here for distance, speed, and time, and the main column is on the journey part, correct? So journey is in two parts, and we know the total journey is of 500 kilometers. You subbed in 500 kilometers. We know the total time is 5.5. We got that value. So we have a framework to show us what the real question is. And now what we don't know are the variables, correct? So you don't know what distance was traveled in part one. We wrote the variable as x. In part two, y. And clearly the equation is x plus y is 500. You get your equation. Do you see that? So you can see what the equation could be. Now, we know the speed in part one is 100 and part two is 80 kilometers per hour. Now, what is time? As you can see, time is the ratio of distance and speed. So in the case of time, I related these two and wrote that the time in the first journey is x over 100 and the second is y over 8.
Y over.
We know the total is 5.5, and therefore I got the second equation, which is x over 100 plus y over 100. I mean, I have written a mistake. Y over 80, I should have written, right?
Yeah.
Error. Okay. So y over 80 equals to 5.5. Does it make sense to you?
Yes.
Now you have to solve this system. Equations have been numbered as 1 and 2. How will you solve it?
So you could simplify and take out the fractions.
Yes.
So we could multiply by 100 to make it 100x and 80y.
Okay, you want to cross multiply.
Yes.
So you want to cross, then you will multiply this with 100 times 80.
Yes.
But the better way would be you find what is the lowest common multiple and multiply with that lowest common multiple so that you don't land up with such big values.
Yes.
Anyway, you have struggled in the very first step. Do you realize that? It is not an easy thing to solve when you write your equation in the fractions form. Correct? Can we work it out in some other way? So here is my remarks on this, and that is what normally happens. And it's very obvious. This is a very important question from test point of view. In every test, there will be a question like this, right? Different values, but exactly same question, okay? Now look into this written in red. Can you please read what I've written in red here?
It says avoid taking variables x and y for distance. That will lead time in fractions 100 over x and 80 over y. Solve equations with fractions is slightly difficult.
Yeah, I wrote it the other way. Yeah, it's too many mistakes, typing errors. Okay. Correct? Time is distance over this, right? So it's
Yeah.
But anyway, you understand. It is the other way, right? But it is fractions. So once you get with this fraction, it is very, very difficult, right? So we should do some other way. So let's see the alternate method of doing this particular question. So this time what I did was, instead of defining my variables for distance, I defined my variables for time. Do you see that? I changed, I switched. So now I'm saying, forget about distance. Now I'm saying, well, part one, we don't know the distance, doesn't matter. We know the rate of 100.
Yes.
Part B, we know the rate of 80. Total is 500 and 5.5. Now it is up to us what variables to define. Correct? We can define time as a variable. Let's say journey, part one is done in X time, and journey in part two is done in Y time. In that case, distance will be product of these two, right?
Yes.
Distance is product. So distance is 100x, 100 times x. And the other distance is 80y, correct? Multiply these two. And we know total distance is 500. So I get an equation 100x plus 80y is 500. And the first one is x plus y equals to 5.5. Does it make sense to you?
Yes.
This particular approach is far better than the approach we had earlier. Of course, when you cross multiply, you do get the same equation as we were getting.
But bigger numbers.
You get the idea now?
Yes.
But whenever you have distance, speed, and time, distance, rate, and time, I'll prefer you to write variables for time.
Yes. And have distance in. Yeah.
If you write variable for time, there will not be any fractions. Correct? And you have much simpler scenario to work with. Correct? Now, of course, you can easily multiply the first equation by 100. By doing so, you also take care of 5.5, right?
Yes.
And see how easy. Can you read the solution?
By elimination. So it says, avoid taking variables x and y for distance. That will lead time into fractions, which is 100 over, I can't see, 100 over x and 80 over y. Solve equations with fractions is slightly difficult.
Yeah, this was correct, because no, this is correct. I just actually cut pages. Because if I say that, now see, that will lead time in fractions. So time is distance over speed, right? So distance will be x over 100, correct?
Yes.
And that'll be y over 80. Is it clear? So solving equations with fractions is very difficult. So avoid, just as we saw in this particular case. And by defining time, we have no problems. See the whole table? No fractions involved.
Yes.
Do you see that? In examination, it makes huge difference. If I'm making such mistakes in like trying to explain you the things, imagine what will happen to students, right? It's so bad. Okay, now. So when you do this time x and y, distances now are linear kind of, right? 100x, 80y, and you get your solution. So you have two equations. One is x plus y equals to 5.5, 100x plus 80y equals to 550. We can decide on eliminating either one of them. I just multiplied the first one by 100. And we get 100x plus 100y equals 550. Now taking away one equation, which is equation number 2 from equation number 3, so 100x and 100x cancel, and 100 minus 80 is 20y, correct? 550 minus 500 is 50, and you can divide 50 by 20 to get your answer, which is equal to 2.5. Is it okay? So y is 2.5. Correct? Equal to sign was missing there. Since we find the value of y, you can always write x equals to 5.5, rearrange, minus 2.5, so x is 3.
3.
So we have part 1, but in this case, you have to calculate, right? So you know x is 3 and this is 2.5. Substitute the values and calculate the distance. So you get distance as 300 kilometers for part 1 and 200 kilometers for part 2.
For part 2.
Is that concept clear to you?
Yes.
So that is the way to do it, correct? So with that, we come to an end of solving linear systems, correct? Now, I'll like to share with you some more questions which we talked about. Now, you know all the 3 ways of solving.
Yes.
We'll begin with question number 8.
Yes.
So let's remind, tell me what do you understand by consistent? Tell me, when is a system consistent?
So a system is consistent when there's a solution which they overlap.
In 2 cases, it is consistent. Either they have one solution or infinite solution.
Okay.
Having a solution means system is consistent. You understand?
Yes. So that's infinite.
If the system has a solution, it is consistent. It has a solution. Yes. Now, solution could be they can intersect at one point, or they could overlap all the points. If they intersect at one point, then we say they are independent. Okay. If they intersect at all the points, then it is dependent. Now, if they have different slope, they will definitely intersect, right? So if they have different slope, they will definitely intersect. In that case, you can say it's independent and consistent. But let us say they have the same slope. If they have the same slope, they could be parallel. If they are parallel, inconsistent.
Which makes it inconsistent.
But if they are overlapping, that makes it dependent and consistent. You get consistent. That makes sense, right? Now, part C. Y minus 10 equals to 0, x equals to 5. This system is consistent, inconsistent. Why?
It is consistent because they're going to have a point of intersection.
What is the point of intersection in this case?
10, negative 10 and 5.
What is the x coordinate? What is the y coordinate?
The x coordinate is 5 and the y coordinate is, the y coordinate is 10.
So you have to write within the coordinate system 5, comma 10.
And 10.
Yes. Yes. The second equation, is it consistent or inconsistent?
This equation's inconsistent.
Why?
Because there's no, the slope is this, no. Oh, it's a different slope. Okay, so then it doesn't have a solution.
It has a solution. Different slope means they will intersect. And once they intersect, it will be consistent. They will intersect always at a point. Is it clear to you?
Okay.
So kind of review this. And here is a solution for you to go through. So I'd like you to again read this page right from the question till the end, right? So example 8, what does it say?
So it says Analyze each solution to determine the number of solutions given in the system.
Hmm.
Strategies to write each equation in slope-intercept form. Now you can easily read the slope and y-intercept to answer the question.
Correct. So these are your two equations in A. So what I did was I wrote them in slope-intercept form. 3x plus y plus 10 equals to 0. Taking 10 to the right side becomes minus 10. Taking 3x to the right side makes it minus 3x. So this equation has a slope of minus 3, y-intercept of minus 10. The other equation, I have to take minus 10 to the right side, it becomes plus 10. Slope is minus 3. You can see both slopes are same, right? That means both slopes are same. However, y-intercepts are different.
No.
That means parallel lines, correct? So same slope, different y-intercepts. Do not intersect, no solution, inconsistent, right? Because they are parallel lines, correct? Correct? Well, I should draw
Sure,
it.
you're cutting out.
Pardon? So minus means going downwards, right? So I could draw like this. Parallel lines, they will never intersect. Does it make sense to you? Same slope, minus 3 means coming downwards, right? With the same slope, y-intercept is different.
So yeah, it was some reason it wasn't working.
Oh, I see. Okay. Now, is it okay for you?
Yeah, now it's okay.
Fine. So once again. Okay. So let me tell you once again all this. Okay, Nicholas, let's go through this solution once again. We have 3x plus y plus 10 equals to 0. We bring 10 to the other side, it becomes minus 10. 3x to the other side becomes minus 3. The other equation, minus 10, when brought to the right side, becomes plus 10. Now, what is the slope of these two lines?
Negative 3x.
That means they are parallel.
Parallel, yes.
Okay, same slope. Anyway, y-intercept is different. That confirms they are parallel, correct?
Yes.
Coming downwards. Both are parallel. If they are parallel, will they have a solution or no?
No.
No solution. So we are saying that same slope with different y-intercept means parallel. Is that clear?
Yes.
Do not intersect. No solution. Inconsistent. So these are the keywords which you should remember. Is that clear to you?
Yes.
Second equation. X plus 3y equals to 1, 2x plus 6y equals to 2. So if I isolate, we get y equals to minus 1 over 3x and the y-intercept is 1 over 3. The other equation also, when I isolate, I get exactly the same situation. Do you see that?
Yes.
Clearly, they are the same lines. Same slope and same y-intercept means infinite solutions. They are same lines, but they have a solution, one or infinite, consistent, dependent because they are overlapping, correct?
Yes.
This one, y equals to 10, x equals to 5, y minus 10, I should write y equals to 10 since I rearranged it, correct? Is a horizontal line, y equals to 5 is a vertical line. So horizontal, vertical, they will always intersect at one point, correct?
Yes.
And the point is x and y value. And since they intersect, it is consistent system, right? So these are perpendicular lines. They will intersect at 5, 10. Different slope, intersect at one point, consistent, independent. Last question. 2x minus y minus 10, rearrange. Y equals to 2x plus 10. X plus 2y equals to 0, rearrange. 2y equals to minus x, y is minus half. Again, you find their slopes are different, right? In fact, these are also perpendicular lines, right? Negative reciprocal. Different slope, intersect at one point, consistent, independent. Are these terms clear to you now?
So if the y-intercepts are different,
Yes.
and they do not intersect, that means that means it's inconsistent.
Yes. They are parallel.
And then if they do intersect, Okay. And then if they're the same y-intercept and they do intersect, it's consistent.
Yes, infinite solution.
Okay.
So when I say that the slope is same, it doesn't necessarily means they are parallel. They could
Yeah.
overlap. Do you understand?
Mm-hmm.
So you have to check
Yes.
the y-intercept. So if I say they have same slope, you have to check the
The
y-intercept. If
y-intercept.
y-intercept is different, they are parallel,
Then
inconsistent. If y-intercept is same, they're exactly
they are
same,
consistent,
consistent,
independent.
dependent on one another.
Yes.
Dependent on one another. Is that part clear to you?
Yes.
Perfect. So that brings us to the end of our lesson. And that was the point which I wanted to make absolutely clear. So I think you are now good for it.
Yes.
So, so now, basics about lines, absolutely clear to you?
Yes.
You understand what a linear system is?
Uh-huh.
You can solve
Yes.
a linear system by graph. You can
Yes.
solve it by substitution.
Substitution.
You can model real life
Word
examples.
problems. Yes.
You can solve by elimination. You have
Elimination.
learned different strategies. So we learned about making tables and then solving. We also learned a strategy in distance, speed, and time. The variable defined
Yes.
should be for time, not distance.
Not for distance.
Otherwise, you'll land up with fractions.
Because
Nothing is
two,
wrong.
yeah.
Nothing is wrong, but something is better,
It
right?
just takes a little bit longer.
With the help of those questions, we actually did exam review. All the questions which I have taken here were from previous IB test papers, so they should really help.
Yes,
So
I
is that
took
clear to you?
pictures and I'll work on them. Yes.
So I'll also share with you some more videos to
Some
go
more
through
practice questions. Okay.
and some practice questions to do. So over the
Okay.
weekend, try to do
I
most
can.
of it, and
Yes.
we'll begin with the next chapter now. Is that okay?
On Monday. Okay.
Perfect. So I
Okay.
think that's very clear. Now, Nicholas, I'd like you to summarize your learning about linear systems before we close this chapter.
So in the beginning, we learned about a bit about the basics of a linear system, how they could be consistent, inconsistent, dependent, and independent.
Yeah.
And then we learned on the method of learned other ways to like what a linear system is using a table, or we could use substitution to find our answer. And then we moved on to solving word problems by using substitution or elimination. And then we have learned more about elimination today, when to use certain things to find. And then we just finished off with a little bit more practice on some terms.
Yes.
And then, yeah.
That's good.
That's it.
Yeah, that's great. So thanks a lot, Nicholas, and all the best.
Okay.
See you on Monday.
See you Monday, sir.
See you Monday. Bye.